We now continue our look at regression analysis by taking a closer look at how we decide upon an appropriate regression model for our data set. The data set we're going to look at is not linear. In other words, if we look at the data, it does not look like it's a straight line like it did in our last example. And then we're going to use the graph of that data to determine an appropriate model. Again, that model is not going to be a line, but we are going to use the shape of the graph to help influence our decision. And then finally, we're going to use Desmos to help us determine the model and make some predictions. All right, so here's the data we are analyzing, and the x values are at the top, the y values at the bottom, and we're going to see if Desmos can help us figure out a good model for that data set. So let's go ahead and graph this data on Desmos. So once again, we're going to go ahead and make a table. And remember, we go up to this plus up here on the upper left. We go down here to table to get a table. And I know you don't remember what those x and y values are, but I'm going to go ahead and put those in. Our x values were 1, 2, 3, 4, 5, and 6. And then if we go back up here to the y's were -11, -5, -3, -1.1, -0.7, and let me see, -0.3. Right. And you can see a little bit of the graph down here, and it's in green again, which, no offense, I don't like green. Whoops. Where am I? There we go. I don't like green, so I'm going to make them black. You can make yours green if you want. I have nothing personal against green. And once again, I'm going to adjust the x and y values so that they show our graph a little better. So you notice that our x values are between 1 and 6. I'll give a little cushion here. I'll put the x values down here between 0 and 7. And then our y values are between -11 and -0.3. And so I'm going to go -12 to, let's see, I want to make it a little bit positive. So I'm going to go up to 1. So if we look at our data, there it is. And you can tell it's not a straight line. If I try to draw a straight line through that, it would be pretty far away from the points. So the question is, what kind of graph are we going to use? Well, if we look at the graph, it looks a lot like an exponential function. Now, it is an exponential function that is reflected over the x-axis. So the a in our exponential function is going to be a negative number. And also notice that it appears to be getting closer and closer to the x-axis as x gets really large, which means our b is going to be between 0 and 1. And I'll give you another good look at it so you can see again why this is going to be a good model for us. As you can see, when we go from data point to data point, it appears to be curving this way, curving down, 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 and getting closer and closer to that x-axis, just like our exponential functions did. So it's just like our exponential functions did when our b's were between 0 and 1, except it is below the x-axis, so our a value is negative, just as I mentioned before. So now that we know that we want an exponential model, what we're going to do is use the formula for an exponential function. If you remember, the formula for our exponential function was f of x equals a times b to the x. Well, our f of x, our outputs, that's our y's, so we're going to do y1. And remember, we're doing a best fit, so we can't say equals. So we're going to put that little tilde there to say approximately equal to, and it's going to be a times b to the x1. And then notice over here, we now have a really nice curve that doesn't hit all the points again, but it gets very, very close to them, closer than we ever could with a linear function. Also notice down here for our statistics that our r squared, remember that's our correlation coefficient that we're using to determine whether or not we have a good model. is very close to 1. It's 0.9963, very close to 1, which indicates that this is a good model for our function, and it gave us the best possible values for a and b. A is equal to negative 22.4338. It's a negative number, just like we expected, because it's an exponential that's flipped over the x-axis. And then our b is 0.487045. Notice that is between 0 and 1, again, just as we expected. So now, if we've done our regression on Desmos, we found our a and our b value that gives us our best possible fit, and we can now put that into our exponential function. Our e of x is going to be negative 22.4338 times 0.487045 to the x power. And again, now that we have our regression model, we can use that to make predictions about our data. So again, as we mentioned before, our r squared is very close to 1. That indicates we have a good fit. And now we can go ahead and start making predictions. What happens to our y value when x equals 10? Well, we can't get an exact value. That would be too much to expect. But our best guess based upon our data and the regression model that we're using is we put in x equals 10. We figure out what e of x is at x equals 10. That's going to be our y value. So that's e of 10. When we plug in x equals 10, we get negative 22.4338 times 0.487045 to the 10th power. And when we compute that, we get negative 0.01685. And that's our best guess for our y value at x equals 10. All right, so now go ahead and continue your regression analysis. I got a couple new sets of data for you to work on. It's on the file called Choosing Models and Making Predictions that is included with this video.